equations using what we call elimination. So here's a system of equations, and I want you to notice the way they're arranged. They're arranged with the x values first, the plus or minus signs, then the y values, and the equal signs, and then the negative, or then the constants. So basically what we're showing you is this, that the equations have to be in ax plus by equals c form in order to use this type of solving process. Then we look in the equations and see if we can find a couple of opposite terms, either in the x column or the y column, which we call zero pairs. And then when we add the equations together, the zero pair will cancel out. And then we'll solve for the variable that doesn't cancel out. And then we'll use that number, whether it be an x value or a y value. We'll put that back into one of the original equations and then solve for the missing variable. So we'll show you how this is done. So if we go back to this equation, you notice in the first column I have negative 10 and positive 10. And so if that's the case, I can add these two equations together and eliminate those two terms, because negative 10 plus positive 10 is 0. In the next column, negative 4y plus 6y equals 2y. And negative 8 plus 12 in the last column equals 4. Now I just simply divide both sides by 2, and my y value I have found out as y equals 2. So how do you find your x value then? Well, you plug that 2 back into the original equation for y, and then you solve for x. So in that case I had 10x plus 6 times 2 equals 12, and or 10x plus 12 equals 12. So if I subtract 12 from both sides, I end up with 10x equals 0, and when I divide by 10, I get x equals 0. So there's my x value, and I found that by elimination. So my coordinates then are 0, 2. All right, very good. So there's your first answer. Let's try another one. All right, so in this one, next couple of slides, we're going to kind of review the process. So we, first of all, we added together and got rid of the zero pair. Then we solved for y and got 2. We substituted that 2 back in for the y value and in the second equation. And then when we solved it, we ended up with x equals 0. And that was our answers. Okay, let's think of this pair of equations. They're written in the form that we want them to be in. We notice that our zero pair in this case is in the y column. So when we add these together, those will cancel out, and we'll have negative 5 plus 10x with 5x. These cancel out, and then we have 1 plus 4 in the next column, that's 5, and divide both sides now by 5, and we end up with x equals 1. So if x equals 1, then what are we going to do to find y? Well, we're going to substitute this 1 back in for either x here in this equation or x up here in this equation. I'm going to use the second equation just because I like the way it looks. It has more positives in it. So 10 times 1 plus 6y equals 4. 10 times 1 is 10, so I have 10 plus 6y equals 4. Now all I have to do is subtract 10 from both sides. And 4 minus 10 is negative 6. So 6y equals negative 6. Divide both sides by 6. And sure enough, you end up with a y value of negative 1. Okay, so there's your two numbers for your solution. 1, comma, negative 1. All right, let's try one more and we'll be ready for our assignment. So let's go to the next one. All right, so if we look through here, we notice that our zero pair are going to be the 4 and negative 4 here. So those will cancel out when we add. And then negative 9y plus 3y is equal to negative 6y. And then 28 plus negative 4 equals 24. And if I divide both sides by negative 6, I end up with a y value that is negative 4. All right, I'm going to take the negative 4, take it back up, and I'm going to put it in for this y value right here. So I will then have 4x plus 3 times negative 4 equals negative 4. Or 4x minus 12 equals negative 4. I will add 12 to both sides. I will end up with 4x equals 8. Then I divide both sides by 4, and sure enough, x equals 2. So there's our two individual coordinates, and when I combine them together into the solution, it is 2, comma, negative 4. That would be the point where these two equations, if you graph them, would meet. So we've got you a little worksheet to do. Solve systems by elimination part 1, and we'll hand that out to you now. Thank you very much.